People obsesses about battery life, but what if the motor, inverter, or charger fails first and wreck your ownership math? We all hear battery warranty and assume the rest of the car will outlive it. Not always. Today we are tearing open the real-world lifespan of the parts most owners forget. Traction motor, the inverter, and the onboard charger. You'll get surprising numbers, practical tips to stretch their lives, and a clear sweet spot charging routine you can use every day to protect the whole powertrain, not just the battery pack. Stay with me because the part that dies first might be the one that surprises you. Hello everyone, I'm Shayan, an engineer specialized in electric vehicle development. Let's start with the obvious. Modern EVs have fewer moving parts than ICE engine cars, which is great. Electric motors are simple, rugged, and often last a very long time in real world use. Manufacturers designed them to survive the vehicle lifetime, and they don't need routine service like an engine does. Several automotive reviews and reliability write-up notes motors rarely need attention and can last decades in many cases. But rarely isn't never. Motors live in a system, bearings, cooling circuits, and gearboxes for single reduction multi-speed units, which can vary. If the cooling pump fails, or if a bearing goes bad, the motor can overheat or get physically damaged. Bearings and inverter-cooled stator windings are mechanical and thermal stress points that age with the miles and abuse. Next up, the inverter. The inverter is the electronic brain that turns the battery DC into the AC the motor wants. And it does it at high power and high frequency. That means lots of thermal cycling and stress for semiconductor switches. Inverter lifespan vary, and practical industry estimates for similar power electronics put typically lifetime in the 10 to 15 years range depending on thermal management and use shorter if you run the car in severe climates or race it daily. Think of the inverter as electronics that works very hard. Hot and bumpy environments shorten its life. Onboard chargers or OBCs are often overlooked. The OBC converts AC from the wall into the DC to the battery accepts during level 2 charging. It has a capacitors, power semiconductors, cooling interfaces, and control boards, so it ages too. Poor ventilation, dirty connectors, repeated extreme charge events can shorten an OBC's useful life. Maintenance and avoiding overheating helps. Some sources advise periodic inspection and firmware updates to keep OBCs healthy. Finally, wiring. Contactors and cooling pump play a sneaky role in longevity. A failed contactor or corded connection can cause arcing and localized heat that kills electronics. A failed coolant pump raises temperature and forces thermal throttling or worse. The whole system is only as strong as its weakest link. Here's the problem. Buyers focus on battery warranty because it's expensive and obvious. But the economics of ownership depend on the entire powertrain. A battery that's fine paired with a friend inverter or dead charger is still an expensive repair. And because many EV parts, inverters, control boards, cooling hardware are high-tech and specialized, repairs can be costly and slow. The industry has improved EV longevity massively. One recent analysis finds modern EVs now rival ICE cars in lifespan. But that doesn't nullify component failure risks. When critical electronics fail, repair time and cost become the real ownership headache. Let's quantify what matters and what you can do. Lifespan targets and real data. Batteries. Many OEMs design packs for 150,000 to 300,000 miles or more. Warranties commonly cover 8 years or 100,000 miles, but battery degradation depends on chemistry, temperature, charge habits, and calendar aging. High state of charge and heat accelerate calendar aging as well. Studies show state of charge and temperature strongly drive capacity fade mechanisms, so storing and charging smart matters here. Motors. They are designed for long life and often outlast other systems. Routine mechanical failures like bearings, seals are uncommon but possible, and cooling issues create a major risk here. Inverters. Field estimates and component reliability engineering indicate a typical expected service life of roughly a decade, plus under normal conditions. More aggressive use, poor cooling, or thermal cycling shortens that. Onboard chargers. Lifetime depends on environments and load. Frequent high-power AC charging in warm climates stresses components. Keep them cool and firmware updated to reduce the failure risks. And why the sweet spot matters, and what it is actually. The sweet spot I recommend for daily commute charging isn't a trick. It's a practical routine that protects batteries and the surrounding electronics while keeping the car usable and cheap to operate. Here's the approach. Use the level 2 charging at home or work for daily needs. not DC fast chargers. Level 2 chargers commonly deliver up to 7.2 kilowatts from a 240 volt or 30 amp circuits, which is typical for residential installs, supplying enough energy to cover most commuters in a few hours. That power level is gentler on the OBC and reduces thermal cycling stress on the inverter and battery. The US Department of Energy and other guides list 7.2 kilowatt as a common level 2 spec. Aim to charge in the 20 to 80% state of charge window for routine uses. Storage at very high state of charge and repeated full charges increases calendar and cycle stresses. Keeping the pack in the mid-range reduces stress and slowly capacity fade. Many OEMs and battery experts advise avoiding holding a car at 100% regularly if you don't need it for range. Studies show higher state of charge and elevated temperatures accelerate aging. Schedule charging to off-peak or overnight hours and precondition the battery if you expect a DC fast charge later on. Preconditioning moves the battery to an optimal temperature window so the inverter and motor cooling systems don't have to compensate later. Reducing thermal peaks can stress power electronics. The practical math is that many commuters need only 10 to 20 kilowatts hour per day, which is roughly 30 to 60 miles, which a 7.2 kilowatt level 2 charger can add in 1.5 to 3 hours, easily covered overnight. Use local efficiency numbers roughly 0.3 to 0.35 kilowatt hour per mile to estimate daily kilowatt hour needs for yourself. Numbers you can use tonight. If your commute is 30 miles per day and your car averages 3.5 miles per kilowatt hour, you need 8.6 kilowatt hour per day. A 7.2 kilowatt level 2 charger supplies 7.2 kilowatt hour each charging hour in an ideal session. So 1.5 overnight hours gives you enough power. Daily habits like plug in after you get home, set charging to start at midnight, and set max charge to 80% for daily driving is good. This minimizes stress on the battery, inverter, and OBC while keeping the car ready. How this protects non-battery components. Gentle level 2 charging uses OBC slowly and reduces repeated high thermal cycles in the OBC capacitors and semiconductors. Lower scheduled charging reduces on-demand peaks that force the inverter and motor cooling systems to spike, cutting abrasive thermal cycling. Preconditioning avoids high state of charge, reduce the need for big power draws that heat the inverter and motor, thus protecting their electronics and mechanical parts as well. Here's the key takeaway. The cheapest repair is the one you never need. Battery life matters, but protecting the inverter, OBC, cooling pumps, and motor bearings is the often ignored shortcut to low total cost of ownership. A daily routine that uses moderate level 2 charging keeps a state of charge in the middle range and ensures the car's cooling and firmware are healthy, gives you a much higher chance that a major component will last well beyond the warranty window. Industry studies show modern EVs approaching or matching ICE lifespans overall, but the path to that longevity is disciplined thermal and charging management, not just bigger batteries. In other words, if you treat the whole powertrain gently, you reduce the chance of unexpected inverter or charger failure that can be expensive and disruptive. Don't obsess only about battery kilowatt hours. Motors are robust, but they rely on cooling and bearings. Inverters are powerful, but thermally stressed. And onboard chargers age with heat and heavy use. The sweet spot for daily commuting is practical. Use level 2 charging, which is commonly around 7.2 kilowatts, charge in the 20 to 80% window, schedule charging to off-peak hours, and precondition before big charging sessions. Those simple habits reduce thermal stress across the system and protect the parts that are costly to replace or repair. Do that, and your EV's real-world lifespan will be far kinder to your wallet than the headline suggests.